Hey guys, how you doing? It's Coach Scott again with let's start talking about our mole issues, our mole problems. We're not talking about the little beasts that dig a hole in my backyard, which I'm trying to get rid of. No, we're talking about moles, a SI unit, which is used to count things, right? So again, moles, sort of like a dozen, okay? We know there's 12 in a dozen. Well, in a mole, we have Avogadros number, 6.02 times 10 to the 23rd, right? So, of course, we're going to need our calculator. Got our calculator ready to go. And I've got some problems here, and I'm going to work at the odds. Those are similar to your homework. So, how many hydrogen atoms are in 4.15 moles of hydrogen gas? All right. Well, hydrogen, if you recall, well, it shouldn't really matter. So I got 4.15 moles of hydrogen gas. 4.15 moles of hydrogen gas. So you remember our little formula here. Little n equals big N, which is our number of particles, divided by Avogadros number, Na. Okay, so we just sub in and we'll find it. 4.15 moles of hydrogen gas. And of course, we know that hydrogen is diatomic. It's H2, found in nature that way. We'll keep it like that. So, we're looking for the number of particles, the number of atoms. And of course, it's H2. So that means I might have to do a little trick there after we can find the number of particles. That's not an arrow, by the way. Okay, so I'm going to divide by 6.02 times 10 to the 23rd. All right, so do my math. And of course, it's going to be 4.15, wrong one, 4.15 moles H2 times, because I'm going to multiply that to get it out of the denominator, 6.02 times 10 to the 23rd particles of H2. Get my little trusty calculator. I got it. And I'm going to type in 4.15 times 6.02 second double E, 23rd, and I get 2.49, 2.5. So I've got 2.50 times 10 to the 24th particles of H2. Now it asks for how many atoms. So I've got 2 atoms in a particle of H2, so I'm going to need to multiply that times 2. So we'll get it right on the answer key, right? Times 2. And that'll give me, well, 4.996 or 5.0 times 10 to the 24th atoms. Don't forget the exponent. Atoms of H. Because H2 is really sort of like a molecule. All right, let's go down here to 4. How many moles of carbon? It's asking for moles now. So it's asking for, I'm going to put this formula up here. Little n is equal to number of particles divided by Avogadros number. So it's asking for little n here. So let's just sub things in. Little n equals, put our number here. Here's the number of particles, 7.53 times 10 to the 24th atoms of C. Avogadros number, 6.02 times 10 to the 23rd. No unit, right? It's just 6.02 times 10 to the 23rd. So I punch it in my little calculator. 7.53, second double E, 24, divided by 6.02 second double E 23, and I get 12.50. Okay, so that's how many moles we got. That's a lot of moles. 12.50 moles of carbon. Getting the hang of it, it's after you get the hang of it, it's not too bad. How many silver atoms? Oh, let's go down here. Let's do this. Well, okay, let's do that. There we go. That gives me some space. How many silver atoms are in 1.27 moles of silver? Well, let's write our little formula in there. N equals capital N, the number of particles, and that's what we're looking for, divided by Na, which is Avogadros number. So let's just put it in there, 1.27 moles of Ag, that's silver, equals N, that's what we're looking for, the number of particles, divided by Na. So, of course, I'm going to multiply by Avogadros number. That's what that is, 1.27 moles Ag times 6.02 times 10 to the 23rd. And that should give us N. Let's see, 1.27 times 6.02. Second double E 23. So I got 7.65. That's a lot of atoms. 7.65 times 10 to the 23rd atoms of silver. Let's do another one real quick. Why not? All right, last one. Let's do this with osmium. OS, I think. All right, so how many moles of osmium are in 5.11 times 10 to the 24th atoms of osmium? Well, let's see. Let's write our little formula down. N, little n, equals the number of particles, and that's where we're going to put that number there, divided by Avogadros number. So little n is equal to 5.11 times 10 to the 24th atoms of OS, yeah, divided by 6.02 times 10 to the 23rd, whatever, okay, particles. So let's do it. 5.11 second double E 24 divided by 6.02 second double E 23, and I get 8.48837. So let's make it nice and simple. Let's say there is 8.50 moles of osmium. All right, and you can go check these if you want to. But after you get the hang of working with this formula right here, all right, when you see these type of questions, it's not that hard. Figure out what it's asking for. You know what Na is, 6.02 times 10 to the 23rd. And I've always going to put it on a test for you if you need it. So, guys, I think you'll do well with this part. All right. So, anyway, this is Coach Scott saying, see you on the flip side.